Everyone, this is a quick video looking at converting a simple 1D XP SWM model into an InfoWorks ICM SWM network. So who's this video for? Really just anyone interested in converting and understanding the workflow from an XP SWM model into an InfoWorks ICM model. Also those interested in just understanding the level of effort. I will say and be upfront and honest that this isn't a perfect process. There will be some troubleshooting tips in here as well. So every model is different, every model conversion is different, but this will be just a few things that you might want to think about when converting your own model. So the basic workflow for this is to import the XP SWM model from an XPX file into a model group within InfoWorks ICM. The model group will bring in a number of different things like runs and the network itself to be able to help with the transition process. We're going to check through those modeling objects that came through to ensure that everything came through that's needed. So we're going to validate the model, fix anything that needs to be corrected based on that validation, and then commit the data to the database. We're going to run the model and troubleshoot through some issues, and then finally end up with a successfully run hydraulic model. Alright, so first starting off in the XP SWM model, we have here, it's a relatively simple model, just over 150 nodes. We've got a pump station, but a large majority of this is simply gravity flow. The first step in all of this is to export out to an XPX file, just making sure that everything's selected, all the objects, all the variables are being exported. So once we export, hit the export button, it is going to prompt us to save it in a location. I've already done that, so I'm just going to cancel out of here and then hop over to InfoWorks ICM. At this point, this is where we import that XPX file into a model group. This is going to bring a large majority of the things that we need, the network, run information, different things like that. Once I hit that, it's going to go through the process of importing. Right, so once that process done, we do get an error log. A lot of these aren't too important, just saying that there's some empty information. Really all that is that it wasn't in the model originally, but good to take note of what's in there. So different things came over, like the network, annotations, climatological data, rainfall data, as well as runtime information. I'm going to close out the error log and go ahead and open the network. One of the first things you might notice is that the rain gauges, those do show up at 00, so those are all the rain events that were in there. One thing that I like to do is just kind of zoom into my network, and then down in the bottom right corner I can actually take a snippet of the location of my network, so I'm not having every time to open up the network. I've got those values right there. I can go into my points data information and then fill in bulk those values, just so everything is nice and neat, all in the same area, and I'm not having to zoom into that area every single time I reopen the network. Close that out, and you can see those rain gauges have all been moved up to the network. From there, you might notice one kind of major thing that's not included over here for any sanitary model is the dry weather flow pattern. If we flip back to our model over here and take a look at one of these nodes, you'll see that the dry weather flow is included in the hydraulics data rather than the sanitary layer, and that's a majority of the reason why it didn't come over correctly. But if we look in here, you'll see that there is a couple of different temporal patterns. These are just basic ones that actually don't get used. They're just in here for whatever reason. The one that does get used is the residential DWF. A good way to extract this out and make it easy to get into ICM, you will have to come in here and create a new time pattern. So I'm just going to call it what it is in the XP SWM model for consistency, and then add that temporal pattern in here as well. I do want to double check and make sure that the temporal pattern, so I need to name it that same residential DWF WD when I create the time pattern just so everything lines up together. Oh, and time patterns cannot contain spaces, so I'm just going to close up that space and then subsequently come into my node information here. And if I scroll over to the right side here, do a bulk edit just on those. So I'll need to first select by ascending and then select all those that I want to change. Change that current value to residential DWF WD. So that makes it so that all those are matching up with the pattern that's in here. An easy way to bring in the factor information, I can actually pull up the XPX file that I had in there and a notepad style. And if I do that, and if I look for temporal variations, go down, I actually get that factor in a little bit more of a, I'd say, digestible type of copy and paste type of workflow there. So if I just open up Excel, I can paste that information into here and do a quick data transformation, text to field based on the delimited space. If I hit finish there, I can then copy and paste it, but transpose it. So now we get that in a vertical format. If I come in here, copy that, and then go back into my InfoWorks ICM network, close that stuff out, and then just paste those values into there. That's a pretty straightforward way to just do one. Of course, if you have multiples, there might be some creative ways in Excel to be able to do that and then add that into the network here. From there, though, I'm going to close this out, save the data changes there. The other big thing, we do have this rain gauge in here. If we open up the nodal information, you'll see that some of the unit hydrographs in here. So we do have some wet weather flow RTK set up in here. However, if we look at the subcatchments, we don't have any subcatchments listed in here. The reason being, if we go back to our XP SWMM model, those are contained in the runoff value here, and those just didn't come over. A good way of getting those over would be to export out the nodes into a shapefile. You'll want to bring in the runoff data that's associated with that, so that's going to include the area, the width, the percent impervious, along with the node name as well as node XY. Save that out to a GIS file. I've gone ahead and already done that, so we're going to flip back over into InfoWorks ICM, where I am going to use the Open Data Import Center to bring that information in. Go down here and select subcatchment, select that shapefile that I saved out, and then map everything together. So the subcatchment, I'm just going to use the node ID. This is going to drain to the specific nodes, and then the outlet, which is the name of the nodes, is the value right there. The area, of course, is the area, XY data, and then finally the width and the slope, or the, not the slope, the percent impervious. Once I import that, it's going to tell me I've imported all those values. I can close this up and then now look at my subcatchment information for all that data that's been populated. You'll notice that the rain gauge ID hasn't been populated. You can set this to a new value, and this is a list of all those rain gauges that came over. I'm just going to pick the first one and populate those. You could set up various scenarios for the different rain gauge IDs. Lots of options there to be able to run each one of those different scenario simulations. From here, really the next step is just to validate the whole model. If I hit validate here, we get a list of messages down in the bottom. There's a wide variety of different subcatchments that came in, just because there were some subcatchments that didn't have any contributing area. So with that, we need to go into our subcatchment information, and then we can sort the area by ascending and look at all those areas that are 0. So if I just scroll down to where they stop being 0, I can select all those and then just delete the selection. So that takes care of that. If I go and validate again, we're going to see if we have any other issues going on. We have a duplicate name, so the subcatchment node ID cannot be the same as the outlet that it goes to. So if we come in here, we see that the subcatchment ID is the same as the outlet. The easiest thing to do here is really just to set up a quick SQL query and change those values. So we're going to say change name, open that up, and select the subcatchments. The subcatchments is going to be set subcatchment ID equal to subcatchment ID plus, I'm just going to add an plus and just add S there. So if I save this, I can test it. It's got a valid syntax. I'm just going to make sure that nothing's selected on here, and then open that back up and run it, so it adds that S in there. If I validate again, let's see if we have any other issues going on here. Alright, so now that we've fixed all of the validation errors, we can go ahead and commit the data to the database, adding in initial import as our comment to this. And we can see now that we have a valid run. So if we pull up the run information, all those things are populated in here except for that swim time pattern. I'm going to update to the latest version here and then go ahead and run the simulation. I pull up the job progress window. We see that an initial trial ended up failing. So we do have a location of where the actual IMP file is. There's not a whole lot in these errors, just saying error 2 or 3, typical or a swim type of error, just saying too few items. Not really sure what that means, but we can actually go to the location of the file there. So if we pull up where that information is, we can go ahead and pull up the file that got created there, this IMP file here. Opening it up in XPSWMM is actually going to give us a little bit better of a look. So let's just go back here and copy the location where this is, so it makes it easier to go in and look for what we're looking for. So on the top here, we see that there are too few items at line 1105, this WWF measured storm, the hydrograph in here. If we go back to where we were previously in this dialog, we can open this up and then go to that specific line number to see what might be going on there. So we see that this has to do with some of the RTK information. There's this wet weather flow measured storm. We can see the values for the actual RTK hydrograph that we have in there. If we flip back to our ICM model and navigate to where that information is in the unit hydrographs, you'll see that we have one in here for the hydrograph group as well as the hydrograph unit. So just taking out this is something we just don't need in there. Taking out that's going to end up solving that issue. So with that, I can go ahead and commit the data again. And then go ahead and try to rerun that model, updating the version simulation. You go through and it ends up failing again. This time we look at the error values here. Looks like we have some problems with the pump. So the pump that is in here doesn't have data quite in the right spot. You see that we don't have anything in the pump curve here, and this is where we can go back into the XP SWM model, pull up that pump and look at the pump curve, and just simply copy and paste that data over into here. Pretty quick and easy. There we hit OK. We do need to go ahead and commit that data again. And have everything committed there. And then finally update to the newest version and hit the run simulation. And we can see that that is beginning to pre-process, initialize, and then finally give us a simulation. So finally, wrapping things up here, the results of all this is really just that converting a model doesn't need to be anything complicated, and there are a few tips and tricks to be able to get through some of the issues that you might run into. As always, reach out to support for more help with troubleshooting, especially if you do run into different or unusual problems. And then finally, just because often when we're converting models, there's different engines, there's different versions of engines, just making sure that we recalibrate or at least revalidate when converting these models from one platform to another.